In order to understand how we develop new methods and how we think, I have to start with giving you an idea about systems biology and about system thinking. And we are very much inspired by nature, and we often look to nature to learn things and apply them in science. As human, we are part of nature, so if you look at nature, you also look into yourself. So that's our approach, and that's why on the first slide you already see image I made myself. An image, maybe you recognize, is a flock of starlings. And actually it's taken about 4 or 5 years ago in Utrecht, so in the middle of the city, and near sunset. So near sunset, starlings group together. You see flocks, small flocks everywhere. They come together and they form one large flock, as you can see over here. It looks like a new animal, and it behaves like a new animal. They're not colliding. There's not a boss, so that's probably where it's so nice and harmony. And when you look at it, lots of things has happened. Typically, we refer to these systems as systems of self-organization. And if you like to start, oh, oops, now I did something terrible. I just tried only to use the pointer. I'm back. I'm just, okay, good, I'm back. So, if you look at these starlings and you look at these self-organizing systems and you like to understand something about those systems, then it's getting very important, not just to study an individual starling, but to understand the relationship between the starlings, and especially how they communicate and how information is shared, because they take decisions. As I said, there's no boss. So connectivity is one of the most important things if you like to understand starling flocks. But it's also one of the most important things if you like to study the human body. How are things connected to each other? You cannot really isolate them into details. You could, and you get information, but you need the context to understand what's happening. Now, if you look a little bit deeper to this image, you see also expectation very well expressed, because this is a peregrine falcon, and he sees 70,000 options for dinner. I mean, this is expectation, I would say. So he sees expectation, but all those starlings are grouped together, and it's very difficult to attack those. And they feel quite safe in this type of structure. This unfortunate starling, which you see over there, is a lonely starling, flying alone, has not been able to get into the group. That will be the dinner of the night. So you see lots of things. But if the peregrine falcon comes, you see also all sort of reactions of the starling group. And you see system response. And system response, we will see in health, is a very important issue. Maybe health is not a state, but more an ability to adapt. So lots of different things come to us when we look at those self-organizing systems. But they are highly non-linear. They are dynamic. So we're talking about dynamic patterns of relationship, which makes us intrigued about, can we understand more from that perspective if we look at life or at our human body. Having said so, there is an approach, we started around 2000 with that, which is very biochemical oriented. That means if you measure more and more, you will learn more, and that gives you a lot of insights in the human body. So in systems biology, we typically say, okay, we measure all types of molecules, being transcripts or being proteins or small molecules, thousands of them, maybe in just a blood droplet. We put this all together via different statistical methods, and we can look, of course, group of disease, group of healthy, we can find so-called biomarkers, but in fact we're much more interested at differences at the system knowledge. How different are the regulatory mechanisms in the groups? And we learn also that if we study cells, we can understand a lot from cells, but at higher levels of the organization, you get emerging properties which are very important, and you cannot really see or you cannot really measure if you only look at smaller parts. It's a little bit like when you have a car, when you take it apart and you see everything lying over there, and somebody says, could you point to the functionality of driving? that is very difficult. If you put it together, you get some feeling for it. So it's very important to use both, because both have a lot of information. The detail and the context. So what happens if you do this approach? You start to measure. This is, for instance, a project where we measured about 3,000 different concentrations of molecules. It's a study we did with AstraZeneca to look at side effects of their drugs. And you get patterns like this, very complicated patterns. But you can see patterns which are related to the effects, positive effects, or with the side effects, and you get a feeling for it. In fact, this is a correlation network, and there is a line between two of those dots when there's a statistical significant correlation, which make us sort of get the feeling that they are probably close to each other in the biology, because they move in similar ways in the dynamics of those patterns. So important to know if you do this type of work is that we look, as I said, to patterns of self-organization, and very important, there are thinking patterns embodied as physical challenge. So if you get stressed, this system is absolutely changing. What happens if you have other changes in your thinking patterns? What changes are there, and can you find them? This has intrigued us for a very long time, and has also prompted us to look from a slightly different way to these options. But first of all, we have to have some sort of concept of health, as the WHO concept of health as being a state of complete physical, mental, and so forth wellness doesn't work, because there's always something which is missing. Then we would all be ill here in this room, and we all need treatment. So why not use a slightly different concept? A concept in which you see homeostasis between the green lines, you see the system moving up and down, dynamic system. And suppose I come from the Netherlands, which is not I suppose, but that was the fact. I come to Switzerland, and I'm here maybe higher up in the mountains, and my system thinks, there's maybe less oxygen, there's maybe different circumstances. This is a challenge, but I just adapt my set points. This is called allostasis, and I have an adapted system. When I go back to the Netherlands, it's as it was. I go back again, go back, and there might be a point in time that my system loses the ability to regulate myself back, and I might move into a disease state. Where this line is totally arbitrary, typically where people get some sort of symptom they don't like. But you see this development. And if you look at that development, then of course a lot of our drugs and all our medicine is developed in this area, especially by looking at diseases, and with a concept is called one disease, one target, and one drug. That is a concept of one size fits all, or maybe one size fits none, as you like. But it's very important to see that if we are here in an acute case, this is actually quite a very good approach. But it also has effects if you go in this direction. Let us first look at this part, where you have a very serious disease and the concept. Well, if you think about the concept of this part of the curve, the disease management, then it's very much a type of thinking of disease is a war against. Like with penicillin, you have a bacterium coming in, you throw a bomb on the neck, it's antibiotics. And a lot of those things are like we have to stop something. Names are typically anti-this, inhibitors, blockers. So we're very much focused on stopping something, which is very good if you have a very serious case. But what happens if you use this approach also in chronic situation, or you even try to extrapolate to prevention strategies? Well, then if you look at the effects of medicine, when you use them in a much broader sense, it's what you see over here. Here you see the top 10 highest grossing drugs in the US. And what you see are a number of persons, and in blue are the ones which benefit from the treatment, and red the ones which do not benefit from the treatment. And if you look at this, then you see there's room for improvement. And, and in fact, that also prompted us and many others to say, okay, we need personalized medicine. We need to find out which drug fits which person. So we have done a lot of work I will not discuss today, but it's all about seeing differences between individuals. This is very important. But it's not just looking at personalized medicine from that perspective. If you go back into the curve and you say, okay, but if I'm coming here to prevention or in this area, why am I not focusing on health promotion? Because the system has its own way of maintaining health. How can I improve this? How can I promote health? A totally different approach. But how to measure then health? Well, maybe if you change the definition a little bit towards health is more an ability to adapt and self-management in view of all different stimuli, you can look again at system responses. You all probably know the oral glucose tolerance test, which is a simple approach. You take some glucose, you look how the system reacts. But if you start to look not at insulin, but at how the whole system reacts, you get different information. But it's also very crucial that health cannot be seen as separate from the environment. My health state will be very different up in the mountains here as in Holland. So the environment is crucial, and certainly if we start to think later about more the psycho and social elements which are associated with the environment. So this prompted us to have a feeling that we need to measure more and more. But sometimes we also look in the world and say, okay, maybe we find good references by looking at where people are really healthy. But this concept of self-healing in context is something we try to explore. And what we saw in, for instance, the Blue Zone project is a nice project. That's a project which looked around all over the world. And in the Blue Zone project, they found different places. You see them over here. And people get age of 100, but then also at a much better quality of life than elsewhere. So it's interesting to study what is now so important and why is not the Netherlands on the map or why not Zurich here? You start to ask those questions. Well, if you select 4 elements which are very important, which they found to be similar or at least could explain some of those effects, is that people, they move naturally. That means they're not going to the gym and pumping iron all day. No, they have an integrated way of living and working. So they move naturally. They eat differently, but they eat wisely, so they don't overeat a lot. But then the right tribe, the feeling of the right social surroundings, the feeling of trust and security becomes a very important element. And also a right outlook, maybe a right expectation or other words you like to use for that. Whatever your belief is, if you have a strong belief, it appears it helps you to live much longer. Well, this is of course very interesting. So if you want to measure or do interventions, this certainly should be included somehow in the way we look at people and how we can maybe help them. And of course this has been noted by many other people already before, like George Engel. He already said, well, it's very dominant is biomedical. Why can't we extend it more? Why can't we see it more from social, psychological and other behavioral dimensions, health and illness? So people move to biopsychosocial model, and today we also add all sort of spiritual elements to it. And that brought us for a difficult first question. The first question is, if you are so good in measuring, like things like this correlation network, how can you find differences, phenotypic differences between people, so you can do this more personalized health and personalized medicine approach? And how can you find also the other dimensions which are important for determining the dynamics of these regulatory mechanisms? Well, that's why I often find myself in 2 different phenotypes. The one is here who have just done the measurements, which is very proud to have beautiful measurements. And the other phenotype when somebody from the audience asks me, what can you do with it? So here is a challenge. What can you do with these difficult structures? And we looked to other types of knowledge in order to calibrate our systems in phenotyping. If you take the life complexity pyramid as a start. You see here in the bottom all sort of molecules, and if you go higher in the regulatory status, you see here metabolic pathways, functional modules, maybe organ-organ interaction, large-scale organizations. And what most of us are doing is measuring a lot, trying to figure out how they link together, do all those complexity biology, network biology, and try to come here or even there. But there are other aspects of medicine worldwide which come from the other end. For instance, Chinese medicine is very much a type of medicine which is not looking at the details but describes systems from a phenomenological perspective. And that has been a start of having a look whether we could combine the two in what is called the Sino-Dutch Center for Preventive and Personalized Medicine. Can we use Western diagnosis, for instance, to look at diabetes? Can we use subtyping from Chinese medicine? And then look with our system biology whether we could validate those subtypes. And it's not the topic of today, so I will not say a lot, but if you are interested, you could read the article you find over here, in which we explain that if you want to develop good interventions, you must be sure that the diagnosis is right. So you need to have a very good diagnosis. And what is very interesting from Chinese medicine, that they describe the system from what you see over here, so-called the inner landscape, where they explain how the body works from a contextual perspective, and they explain why certain symptoms are related and how the dynamics of systems are. It's very interesting, and a lot is also known in Western medicine if you start to look from that perspective. So that's why we use this graph you find on the cover also, where you see in the inner side the Tai Chi symbol, and you find the Vitruvian Man of Da Vinci also looked of man in perspective, and you see system biology and the inner landscape together. And we came to the conclusion that there's a very good match, and we showed that for different diseases. So this is nice, but we still said, okay, if we don't get a good diagnosis, we can't monitoring what we're doing, we can't make a step forward. And we showed that for different elements. I will not go into detail. This is another article where you see the complex life pyramid over here. And here you see, for instance, from angina pectoris, how you see in yellow the symptoms which we know from more Western medicine, a lot of other symptoms which are used in Chinese medicine. And you see there come other elements which relate very much to who you are, how your anxiety is, how your discomfort is, and it starts to give you a different view. And we did quite some studies in this area, looking at different indications. For instance, this indication, which has been used by more than 100 million people, showing that if you did some sort of pharmacology, you find all sort of elements which are involved, but especially you found some sort of regulatory mechanism which has to do with the muscle modality, why you could see why heart muscle and your lower back pain, why they relate with each other, and sort of things came up which nowadays again are found by other studies. So we had the opportunity to add things like this to get more other types of elements into the diagnosis. But we still had one very important other question, and that's actually the question and the results I like to share today, which is, okay, could we measure if a system is in coherence? Could we measure that somebody feels happy? And could we feel or measure that somebody is happy or getting happier when he meets somebody else, or that he gets less happier when he meets somebody? In other words, is there any clue that we could measure this? That has been a question for a while, and I'd just like to share with you what we can do today. And for that, I just ask you to go back into nature for a second and listen to the following.
As dusk gives way to twilight, the encroaching darkness is lit by life. These dancing lights around me are produced by fireflies. creatures that have the strange ability to produce light. They bioluminesce. And fireflies are not alone. Scientists are finding ever more strange and wonderful glowing life forms all around the world. Living light has always fascinated me, and the discovery of more and more luminous creatures raises more and more questions. Why? What is the light for? And how is it made? In recent years, scientists have begun to find answers to those questions. And in doing so, they've taken us into a world that is utterly unlike our own. However astonishing these images look, they are all real. With help from new cameras, one designed just for this film, we can reveal this extraordinary phenomenon as it has never been seen before.
It's beautiful, isn't it? If you noticed how the fireflies start to work together, you saw self-organization working. But if you study bioluminescence, it's not just only creatures in the deep sea or the fireflies which are so well known. If you study and look at literature, you will find that every organism, every cell emits light. Also, you are emitting light. And this is very unique in both, wavelengths, timing, rhythms, and so forth. So we're emitting light, but at a very low level. And it's interesting to see whether we could measure that and use that as a new diagnostic insight. And without going into details, but it's long ago, 1923, when Gurwitz showed bioluminescence and communications in onion roots. And this work has been developed further, also in other countries, and it has been used for disease diagnosis. People start to understand the biochemical background, which is typically reactive oxygen species which are formed, into imaging, into self-organizing systems, and you can understand this is where we are heading for. So in this area, I started to work together with Roel and Eduard van Beek, and they did a lot of work here, pioneering work in this area, and we started to see, can we look from a self-organizing system? Well, actually, this is Roel, one of the pioneers, and here you see a very nice image of him in the dark room, because the light intensity is extremely low. That means you have to work in a dark room, and the light intensity is a little bit like a candle at 30 kilometers distance. But you can do that with biophysical measurements, and you can see that the body emits light, and it emits light on different spots. And you can measure that, and of course you can measure different things. You can measure the amount of light, but you can also measure what we call the photon dynamics. That means you look at how the photons come from your body, for instance, by measuring your left and your right hand, and you start to relate the two. And it appears that if you have a very strong relationship between your left and your right hand, that you are getting close to more a harmony or a coherence. And what we did, we looked at healthy people, and I will not go into detail, but you see distribution here, pre-diabetes and diabetes, you see all sort of differences. We could also relate these parameters to the subtyping we found in Chinese medicine. So it gave us a lot of feeling about, hey, we can measure dynamics, we can see the differences, maybe we get a totally new diagnostic tool. We have a couple of PhD theses coming out early next year, but I'd like to share with you some other results which are more in line with what we're discussing today. For instance, stress reduction and health. You can measure different techniques and look at people who do this type of meditation, see whether you can find differences when they do these experiments. So what we do, we have here, you see a dark room, and you have a person there. This is all isolated, and you have cameras which can measure on different spots. Of course, we know the biochemistry changes during meditation, but we like to have a non-invasive type of technology. So we measured 60 subjects. You see them over here divided in other meditation techniques, TM and control subjects. And what we found is there's a lower emission for the TM, OTM group. Some people think that you start to radiate more when you meditate, but in fact the body is much more efficient with energy when you meditate, so you emit less light. And the overall photon emission, so the intensity was much lower in the different meditation groups. Also, we're investigating in more depth these photon distributions. You also see a lot of effects. But somehow the emission patterns over all those points are very identical per person, but there are a huge variation between the different subjects. So that's very interesting result. What's also very interesting is that if you study paramecia, which you find at least in Holland everywhere in fresh water, probably also here, this experiment from Daniel Vels is very interesting. He had paramecia in a closed container and another container over here. When there's nothing in between, this paramecia, the growth rate is as they were together, because they influence each other. The growth rate is determined by the number of paramecia. If you put a visible light filter in between, they behave like isolated groups. That means that the visible light, what we measure, indeed also helps to do the communication between the two groups. And now lots of people are interested in communication and the type of communication we haven't seen before. And Roel and Eduard did a very nice experiment, I think, which we will extend even more, that he looked at the interaction of two humans, in this case a patient and a healer, and they did intentional healing, but then in alternating periods, if you see over here, they did the measurements, but not on the people, but on algae, which were also in the room. And you see that the algae start to oscillate with light differently when there is a non-treatment or a treatment period. So we do feel there must be some sort of communication. We still don't know exactly how it works, but it's also very reproducible. So maybe this human-human interaction could be measured at one point in time. At least we're getting in the area. And this is just something I like to share because we also like to communicate nice things. If you measure hands and you do it in the way that you connect the instrument to different symbols over here, and you transform the light into frequencies which you can play over here, so you get music out, you can start to listen to your own body. And in the museum, Boijmans van Beuningen, we had this setup. You could go in there in the dark room, put your hands in there, and then listen to your own music. So you can listen to yourself, and I remember that first thing I was trying to influence it, but that's not so easy, I can tell you. So we do a lot of those recordings, and we try to see what is the sort of basic patterns for people, and what can you influence, and are they influenced when you get very stressed or something else. So there's lots of things, and I like to close more or less with our types of observations at this point in time, which are that if you are in an interaction between, say, a patient and a healthcare provider, there's lots of things which are happening. We heard of it in a lot today. We look at the patient, we describe them in a way that we take into account all those different levels, family, culture, spatial positions, and so on. But this interaction seems to be very important. And I must say, I also know that from myself as a patient. I've been in many hospitals, also in hospitals where I had a lot of fear. And then suddenly you open the door and you see a doctor who cares about you. And you forget about the hospital and you feel very good. So I think we all sort of realize, and I think it was also very nicely emphasized today, that if you meet somebody and you have a real contact, this is sort of the basis for very good healthcare system. So compassion is very important, and all those variables have been mentioned. In green, I emphasized once more that if you look at placebos or just the effect of human-human interrelationship at a very high quality, that's an effect that really cares for your health. And by saying so, I hope that we start to feel more like the study from Otto Scharmer shows. And he did some investigations in Germany, and I asked people, how do you what sort of level of treatment did you got and what you really want? And then patients and physicians said, well, due to all sort of healthcare limits in time and whatever, it's a sort of repair visit. You come in, you say, complain, you say, okay, this is it, and you go out. But most people actually want to go deeper. Unfortunately, their people are very good, so they can give more therapy or reflection and so forth. And in fact, lots of the healthcare systems worldwide are trying to reduce the intuition and reduce the knowledge of the physicians, while this is the most important aspect, I think, of the healthcare system. But it's very nice if you ask them here in white what you really want. In fact, what they want, they have an issue in their lives and they want to get better or to change their lives. So they're more interested in self-transformation. And maybe the physician becomes more a midwife in such a case. You let the patient move her or himself towards a new position, but you help where you can, and you're not going to dictate what they have to do. So I feel that this is a way of thinking about our future healthcare system. It means that we move, at least in the Netherlands, very much from focus on production to, okay, let's measure your outcome. But we do a lot of measurements which do not really reflect what we are looking for. So maybe we should move forward and try to get more human-oriented care, very much driven by compassion for each other. And in a way, of course, people always like to measure something to have a feeling it works or it doesn't work, especially politics. So we do a lot in trying to develop those methods, at least to give directions towards development of certain systems. So I very much hope that it will work, and you're doing fantastic work. So Claudia, also very happy you have this very nice research group, because I think it's the utmost important to move forward. And then I conclude with some remarks, and maybe I should explain to you also about expectations with this slide. This, in fact, is a slide which was taken in Rome just before New Year, and it just happened I was sitting and reading the newspaper, and I saw there's enormous annoyance in Rome. There were too many starlings, everything was white and whatever. And I looked at my wife and I said, okay, let's go to Rome. And there we had the opportunity to see between 1 and 2 million starlings. And we had a fantastic show. This is called the KISS, this image, because it reflects the interaction we're looking for. And it means that we move, in my opinion, from reductionism more to context thinking, to systems biology. We move from disease thinking to much more personalized thinking, health and wellness. And I think it's reflected in the words, because I is in illness, it's more the isolated case, and it's more to do with relationships like we, as we see in the word of wellness. Thank you very much.